what we're going to do is we're going to replace the laser, the metrology laser, and the Bruker here with a new one, just in case this one has failed. For example, Hugh in Scott Base is going to attempt this for us. This instrument here is the Lauder instrument, the Bruker125. Slightly different from Scott Base Hugh. This one has a vacuum in it, so there's a few little steps are slightly different. The good news is your job is easier. We're going to connect to the instrument's web server, go to a browser. You should have a shortcut there to your instrument, in this case the Bruker125HR. We're going to go, this is actually the instrument we're looking at now. It's a little web server. We'll go to direct control panel, and here we can look at how we control the vacuum, which doesn't exist in Antarctica. This is the Lauder, of course, and the scanner, which is where we will do quite a lot of our changes. So we can initialize the scanner, we can put it into several different modes of operation. We're going to turn the laser off, and before we do that I'll go to stop mode. The instrument might beep, and when we want to get the instrument going again we'll go to reinitialize scanner. So we're going to disconnect and turn off the old laser. So the first thing, turn the power off. The lights die. Back of the power supply, we'll remove the mains connector first. Then we can remove these other connectors at the back. So this is the main D connector for the laser. Undo the thumb screws and that will pull out like that. This is the high voltage connector. This has a lock screw or a lock ring here, so we have to unwind that before we can pull that out. If the lock ring is screwed in, you can't pull it out. The instrument in Antarctica may have another connector in here, status. It goes to a shutter in here that will just pull out. Now I explained that the Lauder Bruckers have vacuum in it, so they have this pipe here, and the Antarctic one doesn't have a vacuum. This pipe is missing. I've got to really disconnect this pipe before we can take the laser out. So the laser is held in by 3 screws on the body of the laser. We're only going to touch these bottom screws, so these are like knurled thumb screws. We're going to turn them probably about 3 full turns anti-clockwise. That's loosened off this bit. You can hear it rattling. There's another one at the front. This is the front one. So again, we'll undo it anti-clockwise 2 or 3 turns. The laser will slide out. In Antarctica, there may be a little bracket in here, and I'll explain that shortly. But the Lauder one, I take the bracket out. So we now just support the body of the laser a little bit as we pull out. And it's quite long, so those cables will end up tucking back in. And now it's starting to come out. And here's the front of the laser. This bit of optics on the front is the beam expander. We want to protect this. So just keep your eye on that and pull the little puppy out. And we have a laser. We have a cord that's no use to man or beast because it's the wrong international standard. The laser tube. Now all this is fairly delicate, so look after it. Put it somewhere where it's not going to roll away. Carefully here. And all the same, the power supply. These are a matched unit, so you can't swap this with the one you've just taken out. So what we're going to do first is label things. Take it out of its little wee bag. Again, you don't want to drop it, it's really delicate, it's got glass in there. Now the next thing we want to do is put the beam splitter on, beam expander on. But before we do that, we'll actually fire up the laser and get it going, make sure it goes. So again, connectors, they only go in one place. Obviously this is a D shaped, it's got to go in the correct way, like so. And we have to do up its thumb screws. Several turns like that. The HT or high tension connector, remember that lock ring? We'll wind it right out so we can pull that back. And we simply pop her in and it goes click. One of these connectors may be used in the Bruker's installations. The status one, it will tells the instrument whether the laser is locked or not, and it operates a shutter, which is absent in the Lauder instruments because I pulled it out. It's a nuisance. It's possibly still in the Antarctic one, so that's another connector. It only goes in the one hole, so there's no ambiguity there. QB plug turned on. Everything's 230 volts, 220 volts. The actual laser itself is universal, so it doesn't matter. You don't have to set the voltage, which is the important thing. So we plug the mains in there, and then we look at the power supply. We turn it on, the red light comes on, laser. After about a second, the laser comes on. Okay. And at the moment it's going through a bit of a stabilisation cycle. It'll be pretty hard to see the beam, but it's trying to lock the frequency and it's trying to lock the amplitude and make them stable. And the way it does that is basically waiting for the tube to warm up and adjusting. Now the reason we put the beam expander on is basically to make the beam, which as you see here is actually really narrow, but it's too narrow for the instrument. We want it maybe 5 mils in diameter, and we may have to adjust it. Each laser is different. There's no guarantee that this is coaxial, like it could be coming out at a slight angle. It might be more collimated than the other one, who knows, but we'll put this on. So again, we're going to screw it on, fine thread. We're going to screw it on by holding on this bit here. This is the adjuster, and we won't do that. So pop her on there. It's going to take just a little bit of mucking around to start the thread. Here you can see the thread. Once we get a bit of friction, start holding it by this bit. Now there's really no need to tighten that up too much. No one's going to disturb it. So I think if you can get maybe 2 or 4 fingers around it, just give it a little tight. And so long as you can sort of make movements with this without unscrewing, that's tight enough. So here we have there. Now, coming out is the beam, nice and clean. So we're going to now follow this beam and just see if it's even. So it's looking pretty good. We can point it at a distant wall. Definitely wider here, but we want to make sure it's not changing its characteristics as we come closer. We can probably improve that. This may take 2 people, because honestly you can't see that far back there, so possibly a good thing for 2 people. How it is now would work. Within the instrument it goes about 3 meters path length total. I'm just going to randomly turn it about 1 turn and just see what happens. That looks like it's narrow at that point. Yep, it's actually looking pretty good. So again, we're looking for about a 5mm diameter beam. If you really want to make it easier, you can actually draw a little bit of a circle as a guide, because they're really difficult things to look at. So there's about a 5mm circle. so it's not too bad. It's pretty good. To be honest, that's about as good as you're going to get. Just out of interest, it still hasn't locked, so it takes a little bit of time. We should get a green lock light coming up fairly soon. So we'll just turn the new laser off, pull out the connectors, again, lock ring, we won't use it. Undo those. And just remember these two belong to each other, so they're both new August 2020, and so is this one, so they're matched. So we'll now put the new laser in the instrument and we'll see if it works. Push the connector end through, really protect this front end here because you've got it adjusted and also it's delicate. Carefully feed her in. At this point you come across the first of the thumb screws, so you need to go above that thumb screw like that, and then keep feeding it in. Okay, so we've gone through the first lot of thumb screws and now we're approaching the other one. So just support this tube get it over this initial thumb screw here, and that's as far as it goes. And you can see we can still adjust the collimator beam expander here if we needed to. Remember, in Antarctica there's another covering over here which we can just unscrew with those 4 M3 screws. This is what we're going to tighten. So this is the bottom thumb screw. Hopefully this is all we need to do is gently tighten this one and the one at the back, and it's in the same position as the laser that we took out. Unfortunately, all lasers are different, so we may have to make some adjustments up the front here. We'll talk about that later, but what we're trying to avoid is having to make adjustments with these other side thumb screws here, which you can see. If we can do it without touching that, that would be great. So we've just done these up finger tight and very loose finger tight, as long as the tube's not rattling. There's no need to crunch it up, no one's going to be in there. So the cords from the new laser, maybe throw a little loop in them just to shorten them up a little bit. Something like that. Cable tie them. I'm just going to poke them over here for now, so the laser's coming out later anyway. The mains is here. The power supply will sit on this shelf. Pop the control connector in. Fits in nicely. The high voltage, it just fits in. Remember the lock nut, we'll just leave it out for now. The status connector in Antarctica is possibly used. Poke that in. Mains. Just carefully feed these cables over the back here, so we can see that. Again, in Antarctica we don't have this tube in the way, and we'll just forget about it just for this exercise. Turn the thing on, red light on, and we'll come back in 10 minutes and the lock light should be on. Before we actually turn the laser on, we'll just stop the scanner so it stops it looking for the laser. So it was probably there, we'll just go to the stop mode. You'll get a few beeps, any random laser signals will make it beep. What we can also do is go into slow adjust mode, which is pretty handy because it actually makes the scanner move without the laser being present. So we still see a signal on the oscilloscope even if it's not a really good signal. So maybe we'll do that. We'll go in slow adjust mode and it just gets the scanner going slowly up and down the carriage. Then we'll have a look at the oscilloscope and see what we find. Here's the oscilloscope. I haven't changed any settings on it, so it should be exactly how you had it. Probably the important thing is that the time display is 20 microseconds per division, or 10 or 40, but 20 is a good start. The voltages are on 2 volts per division each. I think that's how the Antarctic one is set up. It might be slightly different. You can play with it, but this is good enough for now. There's a little bit of random noise on here. This is the laser partly working, so that's a good sign. It means that it's close to alignment. Obviously not good enough. Normally here the oscilloscope lives that way so the operator can see it, and in a similar manner in Antarctica. But what we want to do is actually just move the oscilloscope so we can see it from this end and we can make the adjustments. So we'll now pop round here to the other end and just make a few adjustments and see if it comes to life. I want to tell you now about the adjustments we're going to make to the laser. The pointing of the laser, all the alignment is going to be done at this end of this black laser box. We'll be using mainly these 2 screws here on this mount. This mount adjusts the position of the beam using a prism or a prism mirror. It takes the horizontal laser beam, directs it vertically upwards, and the adjustments are made here. This is called a kinematic mount. It has 3 screws that control where the prism points. This screw here we won't touch. It's a height type adjustment or a pivot. We always adjust a kinematic mount with the diagonal screws. There is a 4th screw. This is a lock screw. We'll probably have to undo it a little bit before we make the adjustments, and at the end of the process we might just lock it finger tight. So the important thing is only touch the diagonal screw. So we have this screw here, which may affect left and right, and this screw here, which maybe is, we can call it up and down adjustments. Essentially they're 90 degrees apart. It doesn't matter how you think upon it. What we do is we alternate or iterate between this adjustment and this adjustment, looking at the oscilloscope, peaking the signals on the oscilloscope so both the A and B laser signals maximize, hopefully at the same time. The process is one, then the other. When we really get down to it, we're doing very, very small adjustments. And just remember, we won't touch the screw here. So you can see I'm sort of down here, crouched on the ground. I've got one hand touching those 2 diagonal screws. It's 2 fingers here, so I'm not touching the one I said we don't want to adjust. I'm looking at the oscilloscope, and I mean, this is unrehearsed. We haven't tried aligning it, but I'm now going to just touch one screw and just see if we get any signal. Look at that. So I'm adjusting one signal, one screw, we get a bit more, and then if I adjust the other one, we get a bit more, and this is a repetitive or iterative process. We go back to the other screw, and then I go back to this screw, and go back to this one, and each adjustment I'm now moving the screw about almost the smallest I can move it. That jump was at the scanner just swapping ends. But we don't actually know what end the scanner's at the moment, because remember we're on slow adjust mode and it's going up and down very, very slowly. I can actually show you that. If we come here and look inside, this is a place you don't want to go. But if you look down in here, you can see the wheels going around very, very slowly. So that's how slow the scanner's going in this slow adjust mode. And I'm pretty certain the scanner is at the far end and it's slowly coming in. And we'll just close that back up. That's where all the delicate bits are. So this is looking very promising. You can see it's unstable. If we touch the instrument, it's because we're in the slow adjust mode. It's not electronically locked or servoed, but we'll change that in a tick. It's a good signal. From memory, I can just see about 9 volts on laser A and about 5 or 6 volts on laser B, so that's pretty good, particularly at this early stage. And we're not even sure if the laser itself is synchronized or locked. We'll see if the green light's on. So here we have green light locked, so the laser's ready, is actually working fine. It's synchronized, it's exactly locked in frequency and in amplitude. So we did our initial adjustments with it in the slow adjust mode there. Remember, the scanner's slowly going forward and back. What we're now going to do is, the most sensitive place to get the signal optimized is at the far end. So we'll click on a short back adjust. We can now use this mode because we've got a laser signal. We didn't really have a reliable laser signal before, which is why we use the slow adjust mode. So we'll now go to the other end and see what signal we've got. So in the back adjust mode, at the moment the scanner's going back a little bit faster because it's going to the far end, so that's why the frequency appears compressed. Importantly, it's fairly stable, it's a fairly good amplitude. Now it's reached the far end, it's just turned around, hit the end stop, and now it's just going to oscillate like this at the far end. This is the optimum place to do our laser adjustments. It's really sensitive. These screws that we adjusted before are now touchy, and we'll just take a small adjustment. So these, I'm moving this thing like a 20th of a turn. I'll just find the other one. If you're not sure, let's have a look underneath what screw you're adjusting. They're so sensitive that even just touching the screw knocks it out of alignment a little bit, so just be really light on the touch. And just try and maximise them. They should both peak at about the same size, the same place. That's probably as good as you're going to get. That's fine, they're good signals. Looks like 10 volts for laser A, which is the top one in this case, and 5 or 6 volts for laser B, so that's good. What we'll do next is bring it in close and just see how much different it is. It'll be slightly more as it gets closer, but it's going to work fine. So we can turn the oscilloscope around. Remember, the scanner's still at this end. I can now see that we've got 10.6 and 6 volts. Laser A, laser B, laser A on the left, laser B on the right. What we can do is go to short front adjust now, or front short adjust mode. It'll now move the scanner fast down the track. So the scanner is now moving down here. Shortly we'll be at this end and it will oscillate here, and we'll just see how different the signals are. They should be a little bit stronger. And, you know, we can look at card signals. Typically we should see maybe another volt or two on each. The close end as opposed to the far end. As it goes towards the front, you can actually see whether it's getting bigger or not. Perhaps it's growing a little bit. And remember, it's going faster, so there's more oscillation shown in the display. There it is at that end. And my eyes aren't good enough, but 10.6, 6.3, so that's just perfect. They're almost the same, just a little bit higher intensity, particularly on laser B. So perfectly aligned laser. The job's done essentially. Next trick is to do a cell test. In Lauder's instance, we now have to put the vacuum pipe back on. Now we've finished measuring the signals. We've written them in the logbook or the spreadsheet, and we can go in it scanner, and that just tells the instrument it can find the home position, and we're ready to take measurements.